Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we will learn how to use the payment function in Excel to find the coupon rate of a bond. In any intro finance class, you will have a unit on bonds, and we professors will always have questions where we give you forward the bond's characteristics and ask you to find the missing one. If you want to ace those questions, this video is for you. I have prepared a standard bond question right here that is asking us to find the bond's coupon rate. Another version of this could ask us to find the actual coupon payments themselves. But since coupon rates come after finding coupon payments, I'm going to solve for the coupon rate. Now, to get started, for any bond question, it's best to convert our verbal description into our bond characteristics for our known variables. So, our bond has a maturity of 10 years, and this is a semi-annual bond. So 2 times 10, 2 per year, we have 20 periods in this bond. Our interest rate, our yield to maturity is 5%, so it's going to be 0.05. Our present value is always the bond's price. Price is $1,100. The payment is our coupon payment. That is what we don't know. We're going to leave that blank. And our face value or par value is our future value. And like every bond, it's going to be $1,000. That is what pretty much every bond you ever see will have. Now, I'm now going to change the price to be a negative number. This is because the Excel function is not going to work unless I use the correct signs on present value and, in this case, just future value. The Excel function assumes that we are solving this question from somebody's perspective, either the person purchasing the bond, which is what we're going to do, or the company issuing the bond. From the person doing the purchase, from their perspective, the price is cash going out, therefore it's going to be negative, an expense for them, and we will put it in as negative 1,100. If we don't do this and we give the wrong signs for present value, future value, and if payment was actually in the function payment, then we either get an error message if we're lucky, or if we're unlucky, we'll get a number and the number will be wrong. And we might not realize that there's something wrong if we just see a number pop up. Now we'll go to our cell next to payment and type equals PMT. Excel will display the parameters that we enter into the payment function. Our first parameter is rate. That's our yield to maturity. So we put in 0.05, make sure it's a decimal. Then is NPER for number of periods. We have 20 periods. Present value, PV is what that stands for. We put in our price, negative 1,100. And future value, FV. This is in brackets because Excel has a default value. Excel's default value is 0, but 0 is not our value, right? Because the face value of the bond is 1,000, so we need to put in 1,000 and not leave it as default. Type also has a default value. We can leave it alone. If we don't enter anything, Excel will still use the correct value. And we now see that our coupon payment per period is $58.02. Now, since payments are semi-annual, this means we're going to get paid $58.02 twice a year, which means our annual amount is 58.02 times 2, 116.05. So this is the annual coupon amount that you receive if you have purchased the bond. And then the coupon rate, which is what determined our amount of 116, the coupon rate is multiplied by the face value to give us our coupon amount. So I can reverse this by dividing my annual coupon amount of 116 by the face value. That gets us to a coupon rate of 11.6%, and that is the coupon rate that this bond is paying. Now, if we want to get a little fancier, use better Excel practices, and most importantly, be able to reuse this Excel file for any future bond questions asking for coupon rates or coupon payments. We can use Excel references. I've already used it here for coupon amount and coupon rate, but I'm going to use it for my function as well. So instead of putting in all the values, I will now tell Excel what cell it should be looking at to have those values. So rate is 5%. I put it in here in B7, so I type in B7. Now Excel knows I'm going to go to B7 to find the interest rate. I can also click, so number of periods was in B6. Present value was in B8. And future value is in B10. Once again, type can be left alone, so I hit enter, and I still get that exact same 58.02. The reason we do this is because then if we see a new bond question with a different value, it could be different length of time, in different interest rate, different price, probably not different face value, but in theory we could have a different face value. We can change the numbers here, and then our value for payment will update, our value for coupon and coupon rate will also update as well because they're also using those cell references. So let's say if our yield to maturity is different, it's 7%, not 5. I would just put in 0.07 here. Payment updates, now it's 79. Annual coupon becomes 158, and my coupon rate becomes 15.888%. So with this single function, we can now find the coupon rate or the coupon amount for any bond question your professor might throw at you. If you found this video helpful, please comment, like, and/or subscribe so other students can find this too. Happy studying.